Hi students, so I came with one more proof. So that is an extension for yesterday's previous video. So let's see. Estimation is unbiased. Now what we have to do is we have to prove that estimation, whatever the estimation example we took, we have to prove that one is unbiased and it should not be consistent. We have to prove that one. So first let's recall what is unbiased and what is not consistent definitions. Okay. So an estimated theta cap, in the sense what cap indicates that we are going to find out. We are going to find out the unknown value. So an estimator theta cap is unbiased if expectation of theta cap equals to theta. That means what? Whatever we are going to prove, we have to satisfy this equation. Okay, so next, not consistent. Not consistent in the sense what? Yesterday we discussed that if the consistent, if you want to prove consistent as n turns to, that means sample size increases, uh, its value go near to the population mean value. That means if you increase the sample size, so the value will be near to the population parameter. But here we are speaking about not consistent. So that means what? An estimated theta n is not consistent if it does not convergence, does not converges in the sense what? It does not change, it does not go near to the value of population parameter. Okay, in probability as n turns to infinity. That means if we increase n value, if we increase sample size, so it doesn't change anything. That is called as not consistent. Okay, let's see one example. So consider the estimated theta n equals to x1. So this is a estimator for the population mean mu of a sequence of identically and independent random variables. IID in the sense what? Identically independent random variables x1, x2 and so on xn with mean mu and finite variance sigma square. That means what? This estimator is having mean mu and variance sigma square. So here we are going to prove the first one, that is unbiased. Okay, so we are going to prove this one unbiased. So see here, expectation of theta n equals to, what is theta here and what is the estimated value here? So x1. So that means x1. So it is come from where? It is come from the random variables which is having mean mu. So that's why we kept here this value is mu. So that means see here, expectation of theta 1. If it took theta n value 1, so expectation of x1 only we will get. Why? Because here theta n is there, no, so whatever the value we took here, that value doesn't change, it will be same x1 only. If you take 100 also, its value is x1 only. So that's why it totally, it's from what? It's from the variables having mean mu. So that's why it is equals to mu. Okay, so this equation is satisfied. So that's why it is a unbiased. So the estimator is unbiased. Hope you understand. So next is consistency. So consistency what? Again we have to take this theta n equals to x1. Does not depend on the sample size. Yes, no? Yes, here if we took how much value also, the final answer is the same. It is not going to change anymore, isn't it? If we took the n value 10, 20, 30, 100, 1000, whatever we take, the expectation value is x1 only. There is no change in it as n increases. Okay, so x1 does not change and does not get closer to true value. Okay, it does not get closer to true value. What is true value? True value is nothing but population value, population estimated value with mean mu. So therefore theta n does not converges to mu. Why? Because it is not going closer to the true value, no? So that's why it is not converges to mu. Okay, so symbolically we can say that theta n equals to x1 does not converges to mu as n turns to infinity. That means n value, if we go on increasing, it does not change anymore. Why? Because whatever the value you take here, it remains same. x1 only we have to take, and this whole term is equals to mu. So that means there won't be any change. So therefore we say that theta n is not consistent. So consistent in the sense it should change. But here we are speaking about, we are discussing about what? Not consistent. So that's why we have consider this example. Okay, hope you all understand. So stay tuned for latest videos and subscribe, share with your friends and comment if you want any videos, okay, on any topic. Thank you. Have a nice day. Hope you all fine.